Great. So this is question 9. We're in the quadratics kind of polynomials area. Sketch the curve y equals 12 minus x squared. Now, if we're going to find the intercepts with the axes, then we need to start with that bit and think, how can we do that? We've got the curve y equals 12 minus x squared. Now, the first thing is it's going to cross the y-axis when x is 0. So we'll look at that first. If x is 0, y would be 12. So that gives us 1 point of intersection with the axes before we do anything else. Let's think about where it's going to cross the x-axis. That's when y is 0. That gives us 12 minus x squared is equal to 0. We might feel confident enough to factorise this straight away. Or we might feel happier if we multiply everything by -1, take everything to the side and deal with that there. Does that factorise now? We can ask the builders if it factorises. How does it factorise? Somebody factorise it quick? Okay. So we've got x plus 4, x minus 3. So we get, what values do we get as being the points where it crosses then? -4. And x equals 3. So we've got it crosses the x-axis, the y-axis at 12, the x-axis at -4 and 3. There's one other thing that we can tell from it pretty quickly. There was a negative coefficient of x squared, so that means it was the unhappy negative kind of curve. It was that kind of shape. So I think we're ready to sketch it. I think in the exam paper they gave you axes to draw your solution onto. We've got y is 12. We've got x as being +3 and -4. I've perhaps done this slightly foolishly because it's often easier to draw the curve first and then mark the points later. We'll give it a go. Oh, there we go. Can we pretend that I hit the one that was at 12 and that would be it? We ought to label our axes as well. There we are. It's important that because -4 and 3, I want to draw this again because I've drawn it the wrong side. But because -4 and 3 aren't the same distance from the central point, we need to make sure that we don't get the maximum point at 12 because it wouldn't be. There's more of the curve over on the left than there is on the right. Oh, look at that. So it would actually look more like that, wouldn't it? But the key thing is that we don't have a maximum point at 12 because it wouldn't be. Have I got away with that? I pretty much have. Yeah, go on.
You know when you kind of reversed all the positives and negatives?
Yeah.
Like, would you not have to reverse them back again? So it would be like +4 and -3, or what is that?
It's the values that make this equal to 0 are when either of these brackets are 0. And so that would happen when x is -4 and when x is +3. So if you put x equals 3 back into the equation, then it would give you a value of 0. It's the same, just because we took it to the other side at this stage here, it's the same equation, it has the same roots. Okay, we don't need to change it back. Was it that bit, wasn't it, that you were thinking?
Yeah.
To change it back?
So if you would not changed it and factorised it, you'd get the same roots? You'd write your brackets as being 4 plus x and then 3 minus x. So you would get exactly the same two brackets.
So would you change it over every time the x squared is negative?
I would change it over every time the x squared is negative, yeah. Just because I find it easier to factorise it with a positive x squared coefficient. Okay? Are we happy with that? Now, part 2 is quite nice because it follows directly on from this. It says solve the inequality 12 minus x minus
Oh god.
12 minus x minus x squared is greater than 0. So, when is the blue curve greater than 0? Well, when it's greater than 0, when it's above the axis, and it's there between those 2 points. So actually, for the 2 marks of part 2, we're not really going to do anything else at all. We're going to use our graph that we've just drawn, and we're going to say it's greater than 0 if x is greater than -4 and less than 3. And it all comes from the sketch of the graph anyway. And I would say if we were just doing a quadratic inequality, then we'd be going for the sketch. We'd want the sketch before we answered it anyway. Part 3. Find the coordinates of the point of intersection of this curve and this line. Well, this is now a separate question, really. We're now doing a simultaneous equations. This is great, isn't it? The noise and the board being completely unaligned and it's going great. And this is all on video. Right. What we're going to do with this, we want to try and eliminate one of the variables. The easiest way of doing it is to eliminate probably y, isn't it? If we rearrange this one, we've got y equals 4 minus 3x. So we've now got 2 equations that both say y equals, so we eliminate y between them and equate those 2 statements. 12 minus x squared is 4 minus 3x. Let's gather everything onto one side, and remember that thing, I like it more if the coefficient of x squared is positive, so I'm going to take everything to the right hand side. Minus 3x plus the x there would leave us with minus 2x, I think. And we've got 4, and we're subtracting 12, so that should be minus 8. Are we right with that? I think so. We would hope that this would factorise. It does, doesn't it?
Yep.
We've got minus 4 and an x plus 2 out of that, from which we get that x equals 4 and x equals negative 2. The question said, find the coordinates of the points of intersection. So just having x values isn't enough, we need to go back, and either of these 2 equations should give us the same answer for the y values, but we're going to choose the one that is easier, so we're going to sub these values into that equation. That said y equals 4 minus 3x, so if we sub in x equals 4, y is 4, take away 12, so negative 8. And if we use minus 2, if x is minus 2, y is 4 minus 3 times minus 2, so that would be a negative 6. So that gives us 10. And we will just present our answer in a neat form at the end. So we're going to say the answer is 4 minus 8 and minus 2, 10. And they are the coordinates of the point of intersection, which again is quite a nice 5 marks for that. We made it to the end without too much noise disruption.